Hello everyone, today we're gonna dive into the Dynamo Revit in our lecture. Before the lecture, we wanted to give you brief summary and explanation about what we're gonna do and what the lectures will include. So here you are seeing on the left hand side a script that we created for this lecture, and by using this lecture and the natural language abilities and texting, you will be able to create the buildings and models like you see in the right hand side. By just basically 2 clicks, then you will be able to actually save it as a STL document and start the printing directly from the Dynamo file with 1 click. So if you choose this true option, it will create your model from your speech, then it will save it as a STL and it will start 3D printing with the scaled version you want. Now David will explain a little bit more details about the first part of the lecture, which is creating the structure by using API, LLMs, large language models, and Dynamo, and then creating a 3D model by using the Dynamo and LLM output on Revit.
In this part of the pre-lecture activity, I want to demonstrate you an application that we have created inside of Dynamo. The main idea of which is to generate floor plan and 3D models with generative AI. Its features include natural language processing and speech to text. For the programming side of the application, we use visual programming in Dynamo, which is shown here in this picture. Now I want to show you the layout of our application. This is the entire Dynamo layout. At the first glance, it might look terrifying, but it is actually easier to understand. This part is the main module of our program. We communicate and receive information with AI, and the right side is the actual component creation part. We will take the walls as an example. To create a wall, as shown in this node, we need a curve, start level and end level, and a wall type. As you can see here, we have manually selected the start and end level and the wall type. So what we are getting from the main module here is the starting point and ending point of the wall curve. So it is basically drawing 2 points and connecting a line between those 2 points. With such a line created, we can then use this node here to create the actual wall for our model. As for doors, exit doors, and windows, we are basically just inserting those components into the wall that we have just created. What is crucial for creating such an application is to understand how Dynamo construct those components. For example, just like the wall that I have just explained. And with the help of API, we can customize the way that AI responses to our input. And with the customized feedback, we can then feed those information into various different nodes to generate the model that we desire. Now let's take a look into the Python code that is responsible for communicating with the AI in the main module. As you can see, it's open here. It's basically the same script as this one. As you can see, it's a couple of 100 lines long. It might look intimidating, but with the help of generative AI, we will guide you through a similar process to create a simpler version of the application in class. Now when we run the script, such GUI will be created. Here in this text field is the place we can type in our wishes to change the floor plan. Here we can choose between different models. Here we can choose transcribe or translate, meaning that we can speak in any other language and the model will still work. Here we can upload a recorded audio file, for example, from another colleague. Here we can choose that we are speaking in real time. Now I will try to make the bathroom bigger with this command. As you can see, the model returned the new coordinates of all the nodes and made the bathroom bigger. Now I try English. I want to add another bathroom to the left side of the living room. As you can see, this was the correct command. Now let's try Chinese. 我想在客厅下方再加一个厨房。As you can see, the Chinese text was recorded and translated into English, and the right floor plan was updated. We hit here create. Some components cannot be added. I will explain later. As you can see here, the 3D model is updated as in the floor plan.
So as you can see, we had a problem in the code. Code was trying to generate, for example, some windows that are actually longer than the wall. For example, take this wall, right? Now it is putting these windows here, but what if the windows actually is larger than this wall? Then it was giving a problem. And now in this code, updated version of this code, we fix this problem, and I want you guys to think about it and tell me in the class maybe the ideas how can we fix such problems. Maybe I should give you some tricks about it. So we are first creating these lines, right? Then we are adding the windows, as you can see here, on the points that where the dots are basically in the middle point of the lines. So imagine if you want to add a windows here, and if it is larger than this line, it is causing the problem, but we can always fix this problem. And I would like you guys to think about it, how can we fix this problem? Maybe I will ask it in the class. Now I want you to talk about the second part of the code, which is actually 3D printing. Now let's start to the demonstration. First, I am running the code. It is creating this graphical user interface that David showed you. Now I will tell, please add the bedroom to the plan. Okay, you already know this part. I will click to create, and the 3D printing part will run after it generates the 3D model. So we are waiting for the 3D model right now. As soon as the Revit file is generated, it will save this file as a STL file to the folder that we specified. And we are right now waiting for the saving. And then we have to slice this STL file to 3D print. To give the code, to create the code actually that 3D printer can understand. So here we are seeing that it is running the software for slicing, and then it will connect to the 3D printer. It connected to the 3D printer right now, and then it will find the latest file for this folder, and it's trying to find it right now. As you can see, after clicking the run, I am not touching anything. It is doing everything with one click, and the 41st file is the latest file. As you can see right now, it imported it. Now it is slicing it. Yeah, it sliced it. You are seeing the G code right now. Now it's gonna start printing. First, it has to heat up this bed and extruder. After heating it up, it will directly start printing, as you can see here. It's basically one click. Now the 3D printing process is going on. This is a workflow that we wanted to show you to actually demonstrate what can be done by using this 3D printer, Revit, Dynamo, and its capabilities. In the lecture, we will ask you a simple task related with this workflow, which is creating a simple wall that is being created by a speech command. For example, you will say, I want a 5-meter wall, and in Dynamo, you will tell it, and on Revit, you will be able to create this wall, which is the actual starting point of this larger and more complicated project. And Thank you for listening. Looking forward for the lecture. See you on Friday.